Hey everyone, and welcome to The Explainer. So what if I told you that you could predict a bullet's path using a tool you probably have open on your computer right now? Yep, today we're going to bridge that gap between abstract math and real-world marksmanship, and we're going to build a ballistic model completely from scratch. And trust me, the method is going to surprise you.
So can you really use basic math to predict where a bullet will land? It sounds super complex, right? But the answer is a huge yes. In this explainer, we're going to dive into how military science uses the fundamental principles of probability to model something as wild and seemingly unpredictable as a bullet's flight path.
And you know, this isn't just some theoretical exercise we're doing for fun. This exact approach is used in military academies to take these really complex theories and make them totally tangible. It's an absolutely brilliant way to get cadets fired up, showing them how math directly applies to, well, their future job.
Okay, so how on earth do you model something that seems completely random? I mean, we're talking about scattering, right? Well, the secret is, it all starts with understanding the pattern of how projectiles disperse. It turns out, even in what looks like total chaos, there's an underlying order, an order we can actually describe with math.
And this is the key to the whole shebang. It's called the normal distribution. You've probably heard of it as the bell curve, right? It's this beautiful, simple idea that tells us that even when shots scatter, they do it in a really predictable way. Most of them are going to land close to the middle, and it gets rarer and rarer to see those extreme misses way out on the edge.
Think about it like this. Imagine you're throwing darts. Where do most of them land? Right? They cluster around the bullseye. And the pattern is pretty symmetrical. You're not just missing to the left all the time. And it's pretty rare to miss the board completely. Well, guess what? Projectile dispersion works pretty much the exact same way.
All right, so we've got this theoretical foundation, this bell curve idea. Now we can start building on it. This is where we move from just noticing a pattern to actually answering some really practical, high-stakes questions by calculating the real probability of a hit.
Yep, this is where the rubber meets the road. The goal is to calculate the probability of hitting a target of a very specific size. We take our understanding of that bell curve and use it to figure out the exact chance of a shot landing inside a defined area. We're turning a general idea into a hard number.
And this is where it gets really, really powerful. This model lets you answer all sorts of crucial questions, like what's the actual probability of hitting a target? How good is this weapon system compared to another one? What happens if we fire a whole volley? You can even start to factor in things like wind. It's an absolutely vital tool for strategy.
So I know what you're probably thinking. Okay, this is going to need some crazy supercomputer or super expensive software, right? Well, here's the big aha moment. You can build a seriously powerful simulation of all this using a tool that's almost definitely on your computer right now.
You guessed it, we're talking about Microsoft Excel. I'm not kidding. Its accessibility is what makes this so amazing. It gives literally anyone the power to bring this complex military model to life. You don't need to know a single line of code.
Okay, so here's the basic setup for our model. It's just a simple table, nothing fancy. For every single shot we simulate, we're going to do a few things. Generate an X and a Y coordinate for where it lands, calculate its distance from the center, and then finally, decide if it's a hit or a miss. Simple as that.
First things first. Step 1. We have to generate the landing spot for each shot, and we use this little magic formula in Excel. Basically, it takes a random number, that's the rand part, and plugs it into our normal distribution model. That 0 just tells Excel our target is centered at 0, and the 1, that's our standard deviation. Think of it as a number that represents how precise the weapon is.
All right, step 2. Time for a little throwback to high school geometry class. Don't worry, it's the easy part. We just used the Pythagorean theorem to calculate the straight line distance from the center of the target, that's 0, 0, to the X and Y coordinates we just generated. See? Told you it was simple.
Step 3 is the moment of truth. Was it a hit or a miss? And for this, we use a super simple logic test with the if function. All it does is ask one question. Is the distance we just calculated smaller than or equal to the target's radius? If the answer is yes, boom, we put a 1 in the column for a hit. If not, it gets a 0 for a miss.
And finally, step 4, we get our answer. This is the easy part. We just use the sum function to add up all of those ones we generated. That gives us our total number of hits. Then, we just divide that by the number of shots we ran, let's say 1,000, and bam, that's our hit probability percentage. And that is the real magic of doing this in a spreadsheet. We're not just doing this for one shot. No way. We're telling Excel to do this whole process 1,000 times, and it does it in the blink of an eye. What we get is a really powerful, statistically solid model of how that weapon performs.
And here you go, a real result. So let's say our target has a radius of 1.5 meters, and our weapon has a precision, a standard deviation of 1 meter. After running 1,000 shots through our model, we get a hit probability of 71.5%. Just like that, we've gone from abstract theory to a hard, concrete number.
But this is where the model really shows its power. What if we start playing with the numbers? We can change just one variable, that standard deviation, the weapon's precision, and instantly see what happens. Look at this. A weapon with high precision, a smaller sigma, gives you this super tight cluster of shots. A weapon with low precision, the shots are all over the place. It changes everything.
So, as you can see, this is way more than just a cool math trick, right? The idea of using a simple, accessible tool like a spreadsheet to teach something this complex, well, it has some really profound benefits, especially for anyone trying to learn this stuff. I mean, think about it. This approach doesn't just teach you a formula, it teaches you a whole new way of thinking. It builds practical skills. It makes these abstract ideas feel totally real and engaging, and it might just get someone genuinely excited about science and math. And maybe the best part? You can run endless simulations, testing all kinds of scenarios, without ever firing a single live round. That's huge. It really makes you wonder, doesn't it? If a simple spreadsheet can model something as complex as ballistics, what other big, complicated, real-world problems could you start to solve with the simple tools you already have? Something to think about. Thanks so much for joining me for this explainer.